So welcome back to iOS YouTube channel. So today we'll be looking at calculus, which is one of the fundamental issues that students face. So in this episode of iOS YouTube channel sections, we will start with the fundamental issues of calculus to the advanced one. So today we start with first principle under differentiation. Don't forget that calculus, we have two sets of calculus. We have differentiation, then we have what? The integration aspect. So under the differentiation one, that's where we can now be explaining the issue of first principle, chain rule, quotient rule, and so on and so forth. But today, we are starting with the fundamental aspect of calculus, which is what? The first principle. How can you apply first principle? How can you solve a first principle questions? We have a general rule, we have a first principle. So let's go. Let's start with this. Suppose that y equals to the function of x, and we want to solve this using first principle. So what we do is that the first thing is the first thing is y depend on x. So that means any change in x will lead to a change in y. So that's the first thing we need to do. So let's state this. Note that any change in x will lead to change in y, all because y depend on the function of x. That is what we are doing now. So the first step you need to do is introduce change to the both sides. Step 1, introduce change to the both sides. So introduce change to that. That means I have y plus change in y equals to f of x plus change in x. That's the first thing when you are solving when you are using first principle. So now what you do after this, you make step 2. Make change in y as a subject. Make these as a subject. So that means you are making this as a subject. Y will have to go to the other side and the sign will change. That means change in y will now equals to what? A function of x plus change in x minus y. Hope you are getting it now. A function of x minus y. Then move it to the other side. Recall, let me put it there. Recall that y equals to a function of x. So anywhere y is, I can easily change it to function of x. So that means I'm having change in y will now equals to a function of x plus change in x minus function of x. Then that's what we have. So we have now changed this thing. Recall that from our initial equation, this is what we have. Now we have now changed it to what? Anywhere y is now equals to what? A function of x. So what the next thing is step 3. So step 3, divide both sides by change in x. So that means we have change in y over change in x. We now equals to us a function of x plus change in x minus a function of x all over change in x. So we have this. Then you now introduce step 5. No, sorry, step 4. You introduce limits. Introduce limits. Then you say that limits change in x tends to 0. So which is going to give us what we call dy dx, which is this. After introducing limits, we get our final answer for first principle differentiation. Now, whenever you come across this in your exam or text that solve a question using first principle, the first thing you need to do is just prove to this point. I always refer this as a first principle function, because once I get to this first principle function, I can solve any differentiation question by applying this. So to get your full mark, first solve the question to these first three questions. Then any question are given to you to solve using first principle, we can now apply this first principle function to simplify it. What am I saying? You will understand. I'm going to give you some various examples in this video. Please kindly like, share, and subscribe, because you are going to learn a lot. Today, you will find first principle as the most easiest topic under differentiation. I promise you that. Now, we are here now at the step 4 to finalize everything. So now, let's go for example 1. Let's assume that you are given an example. Let y equals to x. And don't forget that is, if y equals to x, that means a function of x is x. Function of x equals to this x. That's what it means. Then using first principle. So this function you get here is what you bring down to this place, which is what? Changing y over changing x will now be equals to what? X plus changing x, then minus f of x, then all over changing x. Are you with me? You will apply this principle because this is the question you want to solve. And why initially I'm telling you that this x that you want to differentiate with respect to y, it means function of x. So the value for the function of x given to us is x. So initially, that's why I'm stating this for you now. So now let's move on. Now, if you want to apply this first principle function, this first principle function that we arrive at here, and that's what we want to just use to solve this question now. So what you will do now is that what this place stands for is to represent whatever x is. This will now be serving as our x. This will be serving our x, whatever x is. Now, since we are using this to replace the value of x here, you don't understand, just watch the video. If you don't understand example 1, you understand 2. If you don't understand example 2, you understand example 3 to example 4. So now, what you need to do now is that this is the same thing as this x. I'm putting it here now, so you will understand what I'm saying later. So this one will be x plus change in x, which is this. Then minus, what is now f of x? Don't forget that our f of x is this. Our f of x is also what? X, all over change in x. So if you now say all over, now the next thing you do is to factorize. Factorize by opening the brackets. That will be x plus change in x minus x over change in x. I'll have this. Then this negative x can cancel this positive x. That means I'll be left with change in x over change in x. So if I have change in x over change in x, that means I can still go further and simplify by dividing change in x by change in x. That means my final answer here is 1. So once I've done with simplification, there's nothing I want to simplify in 1 again. Then I will now introduce what we call limits. So you limit change in x tends to 0. So limit change in x tends to 0 of 1. You will still get 1. If you are limiting change in x of 0 and your final simplification is a constant, what you get is also a constant, because there's nothing you want to substitute 0 in. When we are saying limit, when we are talking about limit change in x 0, that means anywhere you can find change in x, substitute it to 0, replace it by 0, and there's nothing for us to replace it. That's why our answer is 1. So differentiation of x using first principle give us what? 1. That's the first example. Let's move to the second example. Example 2. So example 2, suppose that now we are not using only x again. We are now using quadratic. Let's increase the power. Let the power be more than 1. Suppose that y equals to x squared. By using this x squared, you will understand what I'm saying better. So suppose that y equals to x squared. So what you will have here, if you are doing y equals to x squared, then bring in the first principle function that will first prove. And don't forget that our f of x now is no more x. It is now x squared. Note this. This thing is very important. Our f of x, whatever you have for the value of whatever y equals to is your f of x. Don't forget. Whatever y equals to is your f of x. Now, let's now bring in the first principle function. Then what's that first principle function? It's changing y over changing x which equals to f of x plus change in x, then minus f of x over change in x. This is what we have, guys. Now, let's now solve this. This is, there's something, I don't want you to get confused at this point. Don't forget I told you that whatever s, that s is our problem in this one. That s is our problem in this one. So that means this s is now we have replaced it by using this now. So to simplify this, I'll be having what? X plus change in x. That means this x is this, but the power, we need to introduce it. You know, the other first example, we don't need to introduce power because the power is 1 and you don't need to write it again since the power is 1. So now, don't forget f of x. What's our f of x from the initial function? It's x squared. So minus x squared all over change in x, the initial first principal function. Now, after inputting this thing here, then the next thing is for us to simplify to the lowest form. So, and for us to simplify the lowest form, we need to open the bracket. So, if you open the bracket of this by expanding x squared, I'll be having x squared, then I'll be having plus 2x multiplied by change in x. That's the expansion. Well, that's the answer of this, the expansion that's going to give you. Then change in x squared. If you expand this, what I mean by if you expand this is if you use x plus change in x multiplied by x plus change in x, your final answer, you will arrive at this. Then minus x squared. Don't forget minus this x squared. Then all over change in x. This process is still simplification. We just want to simplify it. Then let's go. Let's see. This negative x squared can cancel this positive x squared. Then nothing can cancel each other, or else we want to divide it. Then to simplify this, I don't want to jump. Then we are left with what we call 2x multiplied by change in x divided by change in x plus change in x squared divided by change in x. This and this still mean this. Because if I collect the LCM of this, I will still arrive at this point. What I just do is to just split it. So now what will now happen? This will cancel this, then this will cancel this. So and by doing so, we will left with 2x plus change in x. Now there's nothing we can simplify again at this point. So what you need to do is to introduce limits. Then limit change in x tends to 0 of what? 2x plus change in x. So that means anywhere I can find change, I'll change it to 0. Then my final answer will have what? 2x plus 0. Then the ds of example 2 is 2x. So if you differentiate x squared, you have what? 2x. Thank you. Let's move to quick one. Let's move to example 4. Sorry, this is example 2. So now let's now move to example 3. Example 3 using first principle under calculus. Always watch iOS class. You will understand. Very simple. And don't forget to subscribe. If you find the video useful to you, please kindly subscribe. That's what is giving us energy to come here. So now, example 3. So in example 3, let's you say that y equals to 3x plus 5. Now, this is another example that I want to use. Y equals to 3x plus 5. Now, don't forget, let me say this again. Don't forget that your f of x is also 3x plus 5. That's your f of x also. So now, but when we now bring in this, your friend, which is first principal function, which is going to give us a f of x plus change in x minus, f of x all over change in x. Now, this is where I don't want you guys to get it wrong. You know, the problem we have with this part is just the value of x. That's the problem we have with this part. So, the one I have interest in is only this x here. I will just substitute this thing and bring it here. I will not put x again. So, what will now be my expression now will now be the constant 3. Write it first. Then this x is no more going to be only x again. We are going to change it to this factor, which is going to be what? X plus Now, we now have what? Plus 5. So, that's for the function. That's for the first function. Then minus f of x. What's the f of x? Go. 3x plus 5. Close the bracket 2. Are we together? then all over change in x. We have this. Calm down, you will understand. Don't worry. So now, let's expand. Let's open the bracket. So if I expand, I want to open the bracket. 3 times this, I'll have 3x. 3 multiplied by this, I'll have plus 3 change in x. Then, okay, plus 5 that is here. That means I've opened the bracket. Now, let's open the bracket by using -2. Minus 3x minus 5. So, all over change in x. So, this is what we have now. Then, let's see what can goes in each other. This -3x can cancel this positive 3x. Am I right? Then this -5 can cancel this positive 5. Then I'll be left with change in 3 change in x over change in x. This will cancel this. Therefore, I'll now introduce limit when I don't have anything to do again. Then change in x tends to 0 of limit 3. Then our final answer is 3. That means dy ds is 3. Example 3. By now, you should understand what we mean by differentiation using first principle. Follow us, subscribe, share to your friend. Now the last example for this class. Okay, let me use something more complex. Such as said, suppose that let's use y equals to x raised to power 3. Now it is not x raised to power 3. Don't forget, always note that f of x equals to x raised to power 3 too. Now, if we now bring in the limits, if we bring in the first principle function, which I first derived. Now, this is why I'm trying to tell you that if you have this question in exam or test, first derive the first principle function. Once you derive the first principle function, then now bring it down to this place to solve this problem. Now, let's bring in the first principle question, that which is what? Y change in y over change in x, which will equals to what? F of x plus change in x, then minus, you have a minus f of x all divided by change in x. This is first principle function. Don't forget. Always no, you don't even to cram itself. Once you can prove it and get it like the way we did it, then you are free to go. Now, this is where I always want you guys to be very careful. Don't forget that I said this particular guy, we only have interest in this x that is here. So that means where I'm going to have f of x plus change in x, we have already changed this to this. So that means don't forget I have raised to power 3 now. Good. Then minus what's now the main f of x raised to power 3. Then over change in x. Now simplify, expand. What will be the expansion of x plus change in x power 3? To simplify this, if I were you, I will use what we call Pascal triangle. When the power is 0, when the power is 1, when the power is 2, Pascal triangle, go back to your secondary school or whatever, or your primary school. So when the power is 3, this is where I have interest. When the power is 3. So because the power here is 3. So if I have interest in when the power is 3, then the coefficient of this one is 1. That means this one will be what? X raised to power 3. Don't worry, we still drop video on how to use Pascal triangle and combination for expansion. So now this one is x raised to power 3, which is what power then plus you now have what's the coefficient here? The coefficient here is 3. 3x change in x. The power here will reduce. This one will have 1 plus 3x multiplied by change in x. The power here will reduce. This one will increase by 1, which will be 2. Then plus change in x raised to power 3. Now this is what we have. Don't forget that we still have minus x raised to power 3. Everything all over change in x. Am I communicating, guys? Thank you. Subscribe. Oh, don't forget to subscribe. It's not easy. So this negative we cancel this positive. Then if that happens, then what else can we eliminate? I'm going to clean this Pascal triangle stuff to move on to the next stage. So now we will be left with this. So don't forget that I did one separation in the previous example. So we still have to apply that to this one too. I will tell you that 3 x squared multiplied by change in x divided by change in x plus what's the next thing? 3x change in x squared divided by change in x plus change in x raised to power 3 divided by change in x. You have this. So then this cancel this. This cancel this cancel this. Then my final expression will have be 3x squared plus 3x. No, this one, yes, plus 3x change in x. Don't forget that this one has square. Then plus 3 plus change in x square. This is what we have. Then you can now, you can now introduce limits because there's nothing for us to simplify again here. Nothing to simplify. Introduce limits. So when we now introduce limit that change in x tends to 0. So that means anywhere there's change in x, we change to 0. So 3x squared plus 3x plus multiply by 0. This one have changed to 0. Then x change in x squared is also now 0. So that means 3 times 0 will also give me 0. That means my final answer, this one give me 3x squared plus 0 plus 0. Then the y ds for the final example is now 3x squared. iOS. The full meaning of iOS is Institute of Scholars. Please don't forget, subscribe, like, and share. This will definitely help you in your test and exam. Thank you. Keep watching.